All right, so this is AP Calculus BC lesson 4-4. This is the ratio test. We had some review on how to do some of these tricks yesterday. If you guys want to send me a picture of that homework, I can give you credit for it. Until then, it will be a missing assignment. I haven't even put it into areas as an assignment yet. So whenever you guys get a chance to send it in, and I'll remind you guys again tomorrow if I still haven't seen anything.
Did we do 4-4 yesterday?
Say that one more time.
Didn't we do 4-4 yesterday?
I still can't quite make you out. Something about yesterday.
She said, didn't we do 4-4 yesterday?
We did not do 4-4 yesterday. We did the preparation for 4-4 yesterday. There's like a bunch of the tricks that you'll need in order to do this lesson. All right, yeah, so today's date is Friday, March 27th. If you have kind of mastered the skills from yesterday, it'll make today's lesson much, much easier. Is there a yes in the nonverbal feedback if you click on participants? Who wants to read our objective for today? Or I guess I could just cold call on someone. Yeah, Arrow, read our objective for today, please.
Hang on, let me move the thing. Use the ratio test to determine if an infinite series converges, diverges, or is.
Exactly, or is inconclusive. Yeah, so this test is really, really powerful. So in lesson 4-3, we saw a test that the alternating series test, and it doesn't tell us that much. This one tells us quite a bit. And I'll also make this additional note that if L is actually less than 1, I'm saying it converges to make it as simple as possible, but if I'm being very specific, I'm saying that it converges absolutely. And converging absolutely versus conditionally, there is a difference. If it's, welcome Chris, if it's conditionally, then that's kind of like the alternating series test. It might converge, but if I take the absolute value, does it still converge? And that's the difference between alternating harmonic series and the normal harmonic series. The normal harmonic series, 1 plus a half plus a third plus a fourth does not converge, but 1 minus a half plus a third minus a fourth, that does converge. So the alternating harmonic series converges conditionally. This one is like a very strong test. It'll tell you a lot. So let's say that we're given some sort of infinite series. Like this is the most general formula I can give you when it comes to an infinite series. Oops. So the one thing I want to say is if I take the limit as the next value divided by the previous value, if that ratio is set up and I take the absolute value, so it's always going to be a positive number. This L is always going to be a positive number. If I take the next term divided by the previous term, I guess, so if I am currently at n, the next term divided by my current term is a more specific way of saying that. What is happening with that ratio? When I take the limit as n approaches infinity, is that ratio, is it less than 1, is it greater than 1, or is it equal to 1? And depending on what you are, it will either converge, diverge, or it will be inconclusive. Inconclusive means it might converge conditionally, it might diverge, it might converge absolutely, we don't know. All right, so let's see an example when we do this. So first, Khan Academy and I and AP Test is going to ask you to go ahead and find that limit. Sometimes on the AP test, they'll just say, does this converge or diverge? And you'll have to apply multiple tests to see what's going on. But for now, we're strictly using just this ratio test. So I need to increase the value of n. This n plus 1 means I'm going to go up a value, and then the denominator is going to be going down a value. So I'm going to go ahead and write this out. We're going to try to find here, what is this ratio? A to the power of n plus 1, or not to the power, a sub n plus 1, all divided by a sub n. I want to find what this ratio is, and then once I find that down here, I'm going to eventually take the limit as n approaches infinity. But simplifying this fraction is the hardest part. And again, please be using that nonverbal feedback to tell me to go slower, go faster. I know that many of you are copying down this problem in its entirety. It's not printed out for you. So n plus 1, that means I'm rewriting this fraction right here, but I'm increasing the value of n. So this used to be n minus 5. If I go up a value, I can think of this as like plus 1 right here. That's going to be n minus 4. That's going up a value. So I'm going to say n minus 4. That's the numerator. The denominator, I'm going to go up a value. This used to be n plus 2 on the inside, and I'm going to go up to n plus 3. N plus 3, and that's still factorial. Now that is all going to be divided by, and again, I could be using this fraction symbol right here. I'm essentially copying on this formula. I just copied down this a sub n plus 1. Now I could do a giant division symbol and do a nested fraction and then do like a sub n down here. But if I did that, I would run out of room. I need this space right here to write the limit. So instead, I'm writing the division that way. I'm going to write it this way, divided by, and now I'm going to do this a sub n. Okay, that a sub n is this fraction exactly. So I'm just going to rewrite this fraction now. This is n minus 5, all of this divided by n plus 2 quantity factorial. So far, all I'm doing is I'm plugging in the formula. I know that this a sub n plus 1 might be a little bit confusing. It just means that n is increasing by 1. I'm pausing and give you guys time to ask questions, to write, to digest the math. And then without further ado, we're going to go ahead and keep it, change it, flip it. I would say 95% of the problems that you'll see for today's homework are going to have a keep it, change it, flip it. There might be one problem where that isn't going to happen, but generally they're all going to be fractions. So keep it, change it, flip it means I'm now going to be equal to keep it, n minus 4, all divided by the quantity of n plus 3 and the quantity factorial. Now multiplied by, and this is going to be flipped, so it's going to be n plus 2 quantity factorial, all of this divided by n minus 5. I haven't done anything tricky or hard so far. So this is where we're using that math that we learned yesterday. What does n plus 3 factorial look like, and what does n plus 2 factorial look like? And this is where we're going to have to do some work on the side. Again, if I had plenty of room, I could just keep going on and on for multiple lines. But if I have n plus 2 quantity factorial, that's going to be n plus 2 times n plus 1 times, et cetera, et cetera, et cetera. What about n plus 3, the denominator? I need to write a little bit smaller. N plus 3 quantity factorial. That's going to be, it starts with, you rewrite it, right? You write n plus 3, and then it goes down. Goes down to n plus 2, then it goes down to n plus 1, then it keeps going down and down and down, which means n plus 2 and n plus 2 are going to cancel out. N plus 1 and n plus 1 are going to cancel out. All of them are going to cancel out except for n plus 3. And notice that there's no more factorial. So if I'm simplifying this fraction, this is kind of like the big drum roll, please, the takeaway from this problem. This is now equal to n minus 4 in the numerator. That's it. Nothing else, because there's nothing else in the n plus 2 factorial. Everything was canceled out. But in the denominator, I have this normal n plus 3 and this n minus 5. This n minus 5. Done. And that's as far as I can go. I've simplified that fraction. I guess I could go ahead and multiply that binomial squared, or multiply these two linear binomials together. Define this is n squared minus 2n minus 15, but it doesn't really matter for now. So I'm like halfway done with this problem in terms of simplifying the fraction. Now I'm going to actually take the limit as n approaches infinity. And again, making sure that my answer is always positive, so the absolute value of whatever this is. But luckily, our answer is already positive, so I don't have to worry about it too much.
Well, I told you.
No one is telling me going faster or slower, which means I'm going to continue on and rewrite this now. So I'm going to say, I'm going to take the limit as n approaches infinity of this thing right here, the simplified fraction that I just found. That simplified fraction is n minus 4 in the numerator. And in the denominator, I can either rewrite this denominator exactly, or I can do a little bit of easy math. I think multiplying the first, like I know that you guys know how to FOIL, first, outer, inner, last. I'm just going to do f first because that's the biggest term. It's going to be n squared and then plus or minus other things, dot, dot, dot. I don't care what happens there because when I take the limit as n approaches infinity, I'm using our top-bottom rules. Our top-bottom rules state, look at the power, look at the degree of the numerator, look at the degree of the denominator. The degree of the numerator is 1 because that's the highest power. The degree of the denominator is 2, because that's the highest exponent. If my denominator has a bigger degree than the top, which is exactly what's happening here, this is equal to something. And this is where you guys actually have to participate a little bit. Is there anyone that can give me a yes in the nonverbal feedback? You have to click on participants at the very bottom. Who knows what this is equal to? What is the limit as n approaches infinity of this fraction? And I don't even need to know the rest of this denominator because I only care about the highest degree, 2. Who knows this? Top bottom rules. And I'm feeling that people are probably still writing this down, which is the reason that you're not giving me a yes. That's what I assume, at least. Maybe that's not the case. I'm getting a lot of people just blankly staring at the camera, which means you don't know. No, Stefan, okay. Well, I will call on someone. Stego. How do you do top bottom rules?
Or just 2 on the bottom.
Say again?
You look at the highest power,
You
which
do?
is 2 on the bottom.
Okay. And what is that?
And 0, Danny.
It's
Danny.
you got it right in the first try. So, yeah, and then I'll give you a quick review on what top bottom rules are. So if the top is bigger than the bottom, so bottom is in lowercase, that's going to equal d and e, or infinity, depending on how you're writing it. If the top is small and the bottom is big, that's going to equal 0. And that's what happens in this case, right? The bottom was bigger than the top. And if the top and bottom are the same size, then that's going to equal a magic fraction. Magic fraction. And magic fraction is just look at the coefficients of the 2 highest degree terms, and it's whatever those coefficients are. So for example, if I come over here, if the magic fraction was something like 3x squared over negative 2x squared, then magic fraction states that this is 3 over negative 2. You just take the coefficients here. Thank you for the crackers, bud. All right. So the answer is 0. Okay, cool. That was kind of the hard bit of the math, right? But you also have to remember what's happening here. So this is the value of L. L is equal to, when I take the limit as n approaches infinity, which I just did, that is L. L is 0. So if you want to write down here, this is L. You can kind of box that. That's kind of the main thing. L is 0. So based on our answer, what does it say about this infinite series up here? If I take this as an infinite series. And then again, this is a quiet raised hand with a yes. Who has a yes that knows what the answer is? Just literally compare it to this table. Which of these 3 things is happening here? Yeah, Fiona?
It diverges.
Not quite. So this means L is bigger than 1. 0 is small.
Converges.
Yeah, converges. So we're in this case right here where L is less than 1. So I'm going to come down here and say converges. Yeah, thank you. All right, so that's your first example. Let's try another one. Again, if you want me to go slower, tell me to go slower in the nonverbal feedback. If you have a question, raise your hand. If you want to participate, give me the yes. Let's do example 2. Okay, so I have a new series. I'm going to go ahead and find this ratio. I'm going to do n plus 1 and then n on the bottom. So this is where I need someone to kind of walk me through it. I know the first part is a little bit tricky. Whenever you see an n, just increase it by 1. So this is now going to be n plus 1. So who can rewrite this fraction, but everything that there's an n, just increase it by 1? Who wants to give it a shot? And I'll help you through it. Like, you don't need to be embarrassed. It's good. Like, making mistakes is going to make us smarter. And I'm hoping someone is going to make a mistake so I can talk about the mistake and then no one else will make that mistake. Otherwise, I will cold call on people. I know that you guys are still writing. I'm trying to pay attention to your cameras, and I see people that are writing. Although, who is this? Because it doesn't say, if I rename, oh yeah, so Gio, I can't see, there you are. And then Chris, if you can start your camera too, that way I can see what's going on, if possible. And if not, you can tell me what's going on in the chat. All right, who wants to give it a shot? All right, Gio, give it your best shot. I'll help you through it.
Oh crap.
I really don't know what I'm doing.
All right, so go ahead and rewrite this, but instead of n, it's n plus 1.
N plus 1.
So tell me what to write.
-3 to the power n plus 1.
Going, and then the denominator is?
N plus 4.
And then add 1 to it, so it's n plus?
Oh, n plus 5.
Plus 5, keep
right?
going.
To the power 8n plus 2.
Oh, yeah, so this, yeah, I'm glad that you made this mistake. So this doesn't have any n in it, so it's not going to increase. You just go ahead and rewrite it. It's built a base of 7, but the power does.
Oh, okay. That's 2. Is it 2n plus 2?
And you don't multiply by 2. You just say add 1. So if it was plus 3, then it's plus 4. If it was plus 1, it's plus
2.
Plus 2. Yeah. So 7 to the power of n plus 2. Yeah, Gio has it. Thank you. Okay, I'm going to go ahead and skip a step. And I hope that you guys are all going to skip a step also, because you know that you're going to keep it, change it, flip it. Let's change it and flip it already. I'm going to change it to a multiplication, and I'm going to flip these two right now and then rewrite them. Normally, I would be copy pasting this right here with a division symbol, but now I'm going to change it, flip it. So this is now going to be the reciprocal, which is, I'm just writing the denominator now, n plus 4 times the quantity of 7 to the power of n plus 1. That's the numerator now. It used to be the denominator. And in the new denominator, we have -3 to the power of n. I just rewrite it, but flipped it. I saved a little bit of work. Oh, and by the way, to make this formal, I should be saying that I'm not taking the limit yet. I'm just finding what is a n plus 1, all of this divided by a sub n. That's what I'm working on. Okay, and very similar to what we were doing yesterday. Oh, look, you see that in the numerator we have -3 to the power of n plus 1, and in the denominator we have -3 to the power of n. There's one more of these -3s in the numerator than the denominator. Or equivalently, I can subtract. I say n plus 1 minus n. I'm left with something. And again, I'm looking at that nonverbal feedback to see when people want to participate. Another one that's kind of easy is I have n plus 1 and I have n plus 2 with those bases of 7. How can I combine those terms using rules or sorry, properties of exponents? N plus 4 and n plus 5 we can't do anything with. The only thing that we can deal with is this -3 to the n plus 1 and this -3 to the n, as well as the 7 and n plus 2 and 7 n plus 1. All right, any yeses at all? Otherwise, I'm gonna have to start cold calling on people. I'm trying to take a look at your cameras as much as possible. It looks like most people are just giving me blank stares, which means they're ready to participate if they had the courage. You got this. Otherwise, I'm gonna force you to have the courage. No, okay. Let's go with Andrea.
Yes, litros más. Yes.
What are we trying to do?
We're trying to simplify now. So I want you to only pay attention to this -3 to the power of n plus 1 and this -3 to the power of n. One is in the numerator, one is in the denominator. So essentially what I'm boiling it down to you for is I have -3 to the power of n plus 1, all of this divided by -3 to the power of n. How would I simplify this as if it was a homework problem from last night? It's the same type of problem.
Do just do you subtract
You do, yes?
n plus 1 minus n, right?
Yeah, so this is going to be now in the numerator, -3 to the power of n plus 1, and then you're subtracting this n, so minus n. Perfect. And that's, if you could simplify it a little bit more.
That's -3 to the power of 1.
María, cuenta las
Which is just
medidas.
-3. Yeah, so that all
Yeah.
goes away. It's just -3.
Abajo. Usa las muertas de control.
I'll leave that up here for now so that people can see it. But yeah, we're taking the numerator, the power in the numerator, and then we're subtracting the power in the denominator. And that's just coming from your rules of exponents. If you don't remember those rules of exponents, you can write this one down as well. Actually, I should leave that. Your rules of exponents state that if I have some common base, so x to the power of a over x to the power of b, this is going to be equal to x to the power of a minus b. This is the rule that I'm invoking, or that Andrea was invoking for that matter. Okay, so Andrea did that piece for us. I already told us that we are going to be rewriting this n plus 4, so I'll say n plus 4, and we're going to be rewriting this n plus 5. There's nothing we can do with those because these aren't the same. If they were the same, then we could cross them off, but they're not, and we can't really deal with them. But I can deal with this 7n plus 1 and 7n plus 2. How can I simplify that one? Again, I'm looking at that nonverbal feedback. Anyone want to give it a shot? All right, Teflon, do your best. You got this.
Are we doing the 7 now?
The 7s, yeah.
So would that be 7 to the -1?
7 to -1, done. Yeah, thank you. So she saw if I'm doing n plus 1 and I'm subtracting n plus 2, the n's cancel out because n minus n is nothing. And then 1 minus 2 is -1. Perfect, done. All right, I'm going to go ahead and simplify this just a little bit for us. So if I have a negative power, that means I can flip to the denominator, and I really have that 7 now to the positive 1, or just 7 in the denominator. And as I said earlier, Andrea's answer simplifies to just -3 in the numerator, which means our super simplified fraction, let me move this over just a little bit. We should say that this is equal to, so I don't make any mistakes. This is now specifically equal to -3 times n plus 4, all divided by 7 n plus 5. We have now simplified this ratio. Okay, you guys know what's about to happen next. Now I'm going to actually do this thing. I'm going to take its limit. So limit as n approaches infinity of -3. And I can actually distribute that -3 if you want, or you can probably see what's going to happen if you don't. So I'll just go ahead and rewrite it verbatim. 3n plus 4 over 7 times the quantity of n plus 5. And yes, we are taking absolute value. I should have written in the last one. This one does matter because if I have a -3, it's not really a -3 anymore. If I take its absolute value, its distance is just 3. All right, so again, I'm looking for those top-bottom rules. Bring them on out. You're looking at the top, looking at the bottom. You're looking at their powers, their degrees of the numerator, the degree of the denominator. What's going to happen with this? Who knows how to use top-bottom rules here? I'm hoping I get at least 2 hands on this one. I see one person has their hand raised. Thank you, Stego. Oh, it's a question, Stego? Yeah, go for it.
No, it's not a question.
Oh, sorry, yeah. I keep saying hand raised because that's what I'm so used to saying, but if you have a yes, that means you're ready to participate. But yeah, if you could go ahead and I'll lower that for you. And if you could go ahead and just tell us how to do this problem.
Is it -3 over 7?
So close. It's absolute value though, so.
So 3 over 7.
3 over 7, exactly. Yeah, can you explain how you got 3/7? Where'd the n plus 4 and n plus 5 go?
You don't really care about them. You care about just the ends. And because they're the same power, you do magic fraction, so you just take the coefficients in the top and the bottom.
Exactly, yeah. Again, so making everyone sees in notes, this is a magic fraction because the top and bottom have the same degree. They're both a degree of 1. So magic fraction, as she said, as Stego said, we're taking the coefficients. The new coefficients, once I distribute that -3 and distribute that 7, the coefficients will be -3n, and in the denominator I'll have 7n. So the coefficients would be -3/7, but we take the absolute value, so the answer is 3/7, and we'll box it. Thank you, Stego, well said. And then finally, what does that mean? Are we converging? Are we diverging? Do we not know? Is it inconclusive? This is an easy way to participate. Who have I not heard from yet? Oh yeah, Chris. Chris, is this converging? Is it diverging? Is it inconclusive? What do we know?
I don't know.
Say again?
I don't know.
Okay, so I'm asking you, is 3/7, is that less than 1? Is it more than 1? Is it 1?
I don't know this one. Is it- Are we convergent?
It is convergent. Why?
This is
Recursion.
less than 1.
Exactly. Yep.
Uh,
No, that's perfect. Yeah. So 3/7 is less than 1, therefore it converges. And technically it converges absolutely. So everyone write down Chris's answer. Chris has the correct answer that it converges. All right. So we're on to our next problem. I know that we only have like 8.5 minutes left of class, and we're going a little bit slow through these notes, but I think it's really good to be thorough. Example number 3. I'm getting a little bit harder, and then do I do a really hard one? No, just a different type of problem. Example number 4. All right. Example number 3. Here we go. I'm trying to give you guys as many different varied examples as possible. But there's like probably 10 different types, so eventually you'll have to use a bit of logic on the homework. Homework is up, by the way, so if you want to rush through these and start on the homework, by all means, go for it. On this one, we're again going to find what is a to the n plus 1, or not to the, it's a sub n plus 1 and a sub n. That's what we're working on. What is that? So another volunteer. How do I do the numerator? How do I rewrite this whole fraction, but with n plus 1 instead of n? It's a little bit more tricky, but it's not too hard. I don't think I've heard from Teflon today.
Yes, you have.
I have? Okay. But can you still do it anyway?
Is it 4n plus 1?
4 to the power of n plus 1.
Yes, and then n plus 1?
N plus 1 factorial, and
Okay.
then on top of that, squared. Good. And then the denominator is
2n plus 1.
yeah, and then there's a common mistake that most students will make. This is not 2n plus 1 quantity factorial. It's 2 times n plus 1 because that individual n plus 1 that's being increased. So make sure that you're distributing that 2 into both of those terms. Yeah, perfect. And then someone else, this is going to be multiplied by something because I'm changing it. I can save a little bit of room here. I need to maximize my room. It's going to be multiplied by what? Because I'm keeping it, changing it, flipping it. So I'm flipping that and multiplying it. What do I have here? Let's give it to Fiona.
Times 2n factorial over 4n times n factorial squared.
Indeed, yep. We just took the reciprocal. Perfect. Thank you, Fiona. All right. Now it's time to start canceling things out. So the easiest thing that I see first is this 4 to the power of n plus 1 and this 4 to the power of n, one in the numerator, one in the denominator. Is there someone that can tell me how to simplify 4 to the power of n plus 1 divided by 4 to the power of n? Yeah, Fiona, again, go for it.
Isn't it just 4?
Just 4. And is that in the numerator or denominator?
Numerator.
Yep, numerator, done. So we've got those. If you want to cross them off, you can to say, yep, we've done those. Good. That's 4. All right. What else do I see here? A lot of factorials happening. I don't want to deal with the squares because that scares me. We'll do the hardest step at the very end. Let's deal with this 2n factorial and this 2n plus 1 factorial. So again, remember that you're distributing this 2 into both n and plus 1, which means I'm going to do some work off to the side because I'm running out of room here. I really have 2n factorial divided by 2n plus 2 quantity factorial. Let's write out what these things are equal to. Is there someone that can help me do this? You remember the way that you write factorials is you start writing the original thing that's given to you, and then you go down a power, or not down a power, you go down to the next one. So if it was 2n, the next one would be 2n minus 1, 2n minus 2, and for example, 2n plus 2, if I start there, then it's going to start with 2n plus 2, then subtract 1, 2n plus 1, then subtract 1, 2n, then subtract 1, 2n minus 1, et cetera, et cetera. So who can rewrite this fraction out just a little bit? Arrow, you gonna give it a shot?
Can you ask the question again? I was working on the homework.
Oh, did you already finish example 3?
What?
You already finished the note?
Kind of, but kind of not. So
ahead.
what was the question?
Write out 2n factorial. I'll give you the first one. 2n times
2n times 2n minus 1
and it goes on and on. Perfect.
times, yeah. There you go. And the bottom one, 2n plus 1 times
Always start with-
2n.
You always start with 2n plus 2.
Oh yeah, the starting one. I forgot about that.
And then the next one is,
2n plus 1.
and then the next one is,
2n.
and the next one is,
2n minus 1.
exactly, yeah. All 4 of those are in the denominator. Thank you. And then Eric, before you leave, what are the things that start canceling out?
Are you still talking to me, Mr. Sindel?
Yes. So Arrow, what are the values that cancel out?
You can cancel out the 2n and the 2n minus 1. So you are left with 2n plus 2 and 2n plus 1 in the denominator.
Exactly. Yeah, thank you. So let's go ahead and write down Arrow's answer. In the denominator, I have 2n plus 2 and 2n plus 1. Okay, so we've dealt with these factorials. I'll cross them off in green. I'm trying to color code this to the best of my ability. Next, I'll do black. All right. So whenever I have factorials squared, and if you guys attempted the homework, that was the hard piece. And I'll go ahead and show you how to do this because we're basically out of time. We have 1 minute and 40 seconds left. If I have in the numerator n plus 1 quantity factorial, and then I'm going to square that, all divided by n factorial squared. In the numerator, I'm just going to work on the factorial. I'm going to pretend that the square isn't there for a sec, and then I'll show you where it comes back in. If it's not there, then this is going to be n plus 1 times n minus 1, et cetera, et cetera, et cetera. And then in the denominator, if I just have n factorial, again, ignoring the square, I just have n, and then I have n minus 1, and then et cetera, et cetera, et cetera. But it's being squared, Mr. Sindel, which means that each of these is being squared. This is n plus 1 squared. This is n squared. This is n minus 1 squared. This is n squared. This is n minus 1 squared. All of these are being squared. And now I've written this out correctly. Okay, well, now that I've written it out correctly, I clearly see there are things on the top, the numerator and the denominator that we can cross off. N squared and n squared, the n minus 1 squared, the n minus 1 squared, and the only thing that's left over is the n plus 1 squared. All right, so I have 20 seconds left. If I can't simplify this anymore, so it's time to take its limit. I'll finish up the video later if you guys want to just check the website. I think We're just going to finish these notes on Monday. So let's go ahead and have no homework. If you didn't do the homework from last night, please get that done and send it to me. And we'll finish these notes on Monday and then do the homework on Monday as well. So the homework is going to be due on Tuesday. Well, it's Monday, so it's time to finish up these notes. Kind of the strategy here is you want to look at the highest degree term. So when I multiply out this n+1 quantity squared, I'm going to be left with n squared plus some other stuff that's not as high of a degree. So really, when I'm taking my limit down here, my limit as n approaches infinity of this function here, it's really going to be 4n squared, and then I'm going to do, I guess I can do plus ... I don't really care what comes after that. And in the denominator, again, if I FOIL this out, again, I'm going to be left with 4n squared plus ... I don't care. I'm just caring about those first two terms. And if you don't know where those are from, feel free to text me or ask me questions via email, whatever. And then from there, I'm kind of just using the top-bottom rules. And I think I have those up here. Yeah, I do. Okay. So, and this is a case where the top and bottom are the same. So it's going to be a magic fraction. Magic fraction states that you take the leading coefficient, and that is your fraction. So this is equal to 4/4 or equal to 1. All right, cool. So it's equal to 1. That is their value of L. I'll come back and say this is equal to L. I come back up to my table and I say, okay, when L is equal to 1, it's inconclusive. So my answer here is it's inconclusive. So I'll say down here, inconclusive. Inconclusive. All right, and our final example before we begin the homework. Kind of yeah, just another flavor, not that much harder. Here we go. So first I'm going to find what is a of n+1, a sub n+1 over a sub n. So I'm adding 1 to all of these. So I highly recommend pausing the video and trying this out on your own first. But here we go. This is 4 to the power of 2. Okay, this n right here should be an n, but now it's an n+1. So n+1 and then +1 because I'm just copying that +1. And then that's all divided by 16n. This used to be n, but now it's n+1. It's not the nth root. If it was inside this index, then it would be an nth root. So it's to the power of n+1, and this is times the square root of n+1. Perfect. That's the n+1. That's the numerator. And then the denominator, again, I'm going to change it, and then I'm going to flip it. So I'm essentially rewriting this fraction, but the reciprocal of that fraction. So it's going to be 4 to the power of 2n+1 goes in the denominator, and in the numerator we get 16 to the power of n times the square root of n. All right, time to simplify this bad boy. Here we go. The first thing that I see is that I have this exponent right here that I can simplify. Distributing the 2 times n is 2n. Nice and hard. Okay, 2 times 1 is 2, but then I'm going to add 1 as well, so it's going to be 2n plus 1 when I simplify that. Plus 3. Oh my gosh, I don't know how to add. 2 plus 1 is equal to 3. Okay, so that's the power up there. And notice that I'm going to be subtracting the power of 2n plus 1. So 2n minus 2n, okay, those cancel out. 3 minus 1, that's 2. So, and that's in the numerator. This is now 4 to the power of 2. All right, I've dealt with those. Chunk, chunk. Now let's deal with another one. I'll choose green. I'm seeing this 16n and 16n plus 1. It's very, very similar. I have the same base 16, so I'm going to do n minus this n plus 1, which is going to be 16 to the negative n, or 16 to the negative 1. I can't speak today. So this is going to be times 16 to the negative 1, but don't write that down, because whenever I have a higher number in the denominator, I should really be writing it down there. And another way of saying it is, if I have a negative power, I can really flip it and turn it into a positive power in the denominator. Either way, we should be writing over, I guess I'll do the over in a different color. It's 16 to the power of 1, or just 16. Again, another shortcut way of doing that without having to deal with negatives is whichever one has the bigger power, in this case this one's bigger because it's plus 1 bigger than the normal one, that's where it's going to end up. If it's in the bottom, it's going to end up on the bottom. All right, so we've dealt with the 16s. Next, the square root of n's, I can't do anything with them, so I'm going to leave them. I'll leave this as the square root of n in the numerator and the square root of n plus 1 in the denominator. That's as far as I can go. Now to take its limit. So I'm going to say, what is the
the limit as n approaches infinity of this thing. I'm just going to copy paste him. I guess I can also simplify a little bit too, because 4 squared, we know that's 16. So I'll come back here and say that's 16. Oh, and then 16, 16 kind of cancel each other out. So I'm really left with what is this is equal to the limit as n approaches infinity of just the square root of n all over square root of n plus 1. And as you can probably guess, you can write this in exponential form too if you want to check this, but this is equal to 1. Why? Again, scratch work out to the side. This is really n to the power of 1/2. Notice a 1n to the 1/2, all divided by, and then again, I'm choosing the highest degree term that has a variable, so I'm kind of ignoring the 1 at this point. It's n to the 1/2 and then plus some other weird gibberish. That's not a good way of explaining it, and it's mathematically incorrect, but that's the best shorty cut. Is that what I want to say? It's a shortcut way of looking at it. Plus dot dot dot. And the coefficients here are an invisible 1 and 1, which is how I got the 1 here. Because it's a magic fraction. This degree and this degree are the same in the numerator and denominator, and therefore I take magic fraction, the 1. All right, and again, this is our equal to our value of L. Once again, it is inconclusive. So I come down here and say inconclusive. All right, that's it for the notes. Please begin on Khan Academy. Text me with any questions. Email me with any questions. Again, my office hours are going to be between 12:30 and 1:30. I'll see you guys in tomorrow's video.